So we're going to look at the converting polar coordinates into rectangular and convert rectangular into polar coordinates. I just review two formulas. And polar coordinates is give you r and give you an angle theta. Okay, rectangular coordinate system. If you have a point, this point is based on the radius r and the theta. This point is based on the rectangular is based on vertical, horizontal x, y, and y values. Okay, so the first formula we learned last week is x equals r cosine theta. R times cosine theta is adjacent. R times sine theta is the opposite side. So y equals r sine theta. Okay. And if we do, if we want to convert the rectangular system into polar coordinates, we got r. If x and y is given, r is square root of x squared plus y squared. Well, you got it, r squared equals, we'll just do r squared equals x squared plus y squared. And the theta is tangent theta equals y over x. Then you get theta equals tangent inverse of y over x, right? Okay. So I think it's just tan theta equals y over x. Sometimes you still based on y and x theta, you have to change it a little bit, depending on the quadrant. Okay, so if I do theta equals tan inverse, it's just the fourth quadrant, first quadrant. It might be second quadrant, have to do a little bit change. Okay, so last week we did 2, so I continue to look at the examples. Convert the rectangle system into polar system. Convert -1, negative square root of 3 into polar coordinates. Okay, convert this into polar coordinates. We have this is x, this is y. So based on the formula, we got r squared equals x squared plus y squared. So r equals square root of -1 square plus negative square root of 3 square. So the radians equals 2. And you got tangent theta equals negative square root of 3 over -1, which is positive square root of 3. Okay, so we solve that one. Theta equals pi over 3 or 4 pi over 3. Okay, however, a question here. So which angle should I choose?
4 pi over 3.
4 pi over 3. Very good. Thank you very much. We have to choose this one. And we need to drop this one because pi over 3 is the first quadrant. And the negative, when you look at the point and here, -1, -3, square root of 3 is here. Both negative. So x and y coordinates is here. So it's third quadrant. So third quadrant is going to be 4 pi over 3. That's why here I only have tangent theta equals y over x. I didn't have theta equal tangent inverse. Because tangent inverse means it's fourth quadrant and first quadrant. It could be either one of these four quadrants. So here is an example. So now I solved that theta. I got theta equals 4 pi over 3. So the corresponding polar coordinates for this one is 2, 4 pi over 3. Okay. And let's look at another one. Okay, convert into polar coordinates. Convert 1 square root of 3 into polar coordinates. I'll give you like 20 seconds to work on this one by yourself. Okay, so most of you should be done here, right? Okay, I'm going to call a student here. Let me call a student here and tell me what you got, okay? So, Bella, could you please tell me what you got?
So R equals the square root of 1 squared plus square root of 3 squared.
Okay, perfect. Then what you got? So equals 2, right?
Yeah.
And then what's your theta?
I didn't get there yet.
Okay. So tangent theta equals y over x equals square root of 3 over 1 equals square root of 3. So tangent theta equals square root of 3. What is the theta? Can you tell me?
Pi over 3 or 4 pi over 3, and then since they're both positive, it would be pi over 3.
Very good. Perfect. Thank you very much, Bella. Very good. So it's just the pi over 3. Since 4 pi over 3 is both are positive, based on this, x and y are positive. This is first quadrant, so we choose this one. So our radians, polar coordinates is going to be 2 pi over 3. So now everyone should have an idea how to convert the polar coordinates into rectangular, convert rectangular coordinates to polar coordinates. So next we're going to convert the equations. Convert equations based on what we're going to use these two formulas. X equals r cosine theta, y equals r sine theta, or r equals x squared plus y squared. So we'll still use these two formulas to convert it. Okay. First example, r equals 4. R equals 4 is very obvious, it's just a radius equals 4. You get is a circle. Since r equals 4, we got r squared equals 16. And then since r squared equals x squared plus y squared, we change the r into x and y, so you get x squared plus y squared equals 16. It's just a circle. Okay. Second one. R equals 3 sine theta. A formula is r squared equals x squared plus y squared. X equals r sine theta, y equals r cosine theta. Okay, so now r equals 3 sine theta. I'm going to ask a student here, what do you think I need to do next? What's the problem? Okay, we have 3 sine theta. Okay, compare with the formulas, which one you think we need to use. I'm going to ask a student here. All right, so Zijian, could you please tell me what do you think I need to do here? Okay, so right here you see r equals 3 sine theta, right? Can I use any of the formula? Oh, x equals r cosine, my bad. Can I use any of the formula? Which one I think I need to use? This one? Or this one? This is sine theta. This one, right? Alright, because this is r sine theta. So compare this one and this one. I have r sine theta. Do I have r here? This is a 3 sine theta. It's r sine theta.
So it's 3 sine theta.
Okay, so compare this one and this one. I want to use the formula r sine theta. What do you think I need to do here? This is r. I need an additional r. If the coefficient doesn't matter, the coefficient numbers never change anything. Right? You just keep that. So from sine theta to r sine theta, what do I need to do? If I want to change the sine theta into r sine theta, Can you press that button?
Multiply.
Yeah, you multiply both sides by r. Because you check compare this one have a sine theta, this one doesn't have an r sine theta. Don't look at the numbers. The numbers doesn't change the whole equation because it's coefficient. What do? I can multiply both sides by r. If I multiply r, I have to do the other side the same thing. So if I multiply this one by r, it's r squared. If I multiply this one by r, it's 3r sine theta. Okay. Now, can I use the formula, Zhijian? This one would be the r squared. You have r squared here, right?
2r sine theta equals.
So this is polar coordinates. This is polar equation. I want to change the polar equation into x rectangular equation. I have r squared here. Now I want to change the r squared into so replace r squared. You have r squared equals x squared plus y squared. So this one you have x squared plus y squared. This one you have this is y. Does it make sense? Do you have a question? So basically, I want to convert the polar equation into rectangular equation. In rectangular equation, you only have x and y. So polar coordinates, polar equation, you have r and theta. But rectangular equation, you have x and y. So I need to change the r into x and y. Change the r into x and y. I don't have the theta anymore if r sine theta equals y. So this equation just a rectangular equation. You will have x and y. You can continue to change this equation a little bit. You have x squared plus y squared minus y equals 0. And you can continue x squared plus y squared minus y plus 1/4 equals 1/4. You add both sides 1/4. You got x squared plus y minus 1/2 square equals 1/4. So this is another circle. Center at 1/2 like this. Oh, I think I made a mistake here because it's just it's 3y. My bad. It's 3y. I missed a 3 here. So it's 3. It's 9. It's 9. So it's 3 and it's 9. So this should be 3/2. Okay. Does that make sense now, Jen? Okay. All right, great. So now we can tell this is center at 0, 3/2, and radius is 3/2. Okay. So this is how you convert a polar equation into rectangular equation. All right. So next one. If I give you r squared equals 4 sine 2 theta. I'll give you 1 minute to work on this one by yourself. Okay, Are you done? I'm gonna ask a student here. Lacey, could you please tell me what you got? What you got for this one?
I'm not done with me.
Okay. So r square. I'm going to write a little bit more for you, for everyone. So for changing sine to theta equals 2 sine theta cosine theta. So you got r squared equals 8 sine theta cosine theta. So my question is here. Can anyone tell me what do you think I need to do next? Based on my previous example here. What do you think? Can you tell me what do I need to do next?
I think we can divide both sides by cosine theta.
We divide both? Okay, we divide. So if I divide cosine theta, you get r sine theta, like this. Then I multiply both sides by r, like that. Or simplify more. Look at the previous one. What did I do? What did I do here? What I did here? I multiply both sides by r, right? So right here, I will still do the same thing. Whenever you see a sine theta, you see a cosine theta, you just multiply them by r. Okay? You want to get rid of the theta because r is never a concern for you. Because r equals square root of x squared plus y squared. It will never be any concern for you, right? But theta it is. So I want to get rid of the theta. We only have two formulas to get rid of it. So r sine theta, x equals r cosine, y equals r sine. So right here what I do, I multiply both sides by, I multiply this one by r because r sine equals 1. So multiply by r, multiply another r again. So you get r 8 times r sine theta times r times cosine theta. So I have multiply r here, multiply r here. Okay, that's just whenever you do that, you see a theta, you want to get rid of that because r is not a concern. Why? Because r, you can do r equals square root of x squared plus y squared. This already is, you can easily change the r into x and y. So here you have r square, then square. This one is r 8 times r sine is y. R times x, r times cosine is x. So just x and y. And r square equals x square plus y square. So it's just x square plus y square, and then square equals 8xy. So now you look at this equation. I don't have any theta, I don't have any r, just x and y equation. Make sense, everyone? Okay. So next one. R equals 2 plus sine theta. All right, I'm going to call a student here and tell me what you got, okay? Travis, could you please tell me what you got?
You multiply both sides by r. R squared equals 2 plus sine r squared, or r sine theta.
Okay.
And then you get x squared plus y squared equals 2r plus 2y.
2r is x squared plus y squared. Because r equals square root of x squared plus y squared. So you can do that. Plus, oh, I don't have y. So it's just y. I think we don't have 2 here. It's 2 plus sine. 2 times r is 2r times r is r sine is just y. Like this, right? Because you only have 2 plus, it's 2 times r. You multiply everything by r. So r squared 2r r sine. R sine is y, so it's like this. Perfect. Thank you very much. This is our final answer. Okay. As long as your equation does not have x and y, does not have theta and r, only have x and y, that's going to be a rectangle equation. Sometimes you can simplify more, sometimes you cannot, but most likely it'll be okay if you just write down this. Okay. So now everyone should get an idea of how to convert the polar coordinates into polar equation to rectangular equation. So next one, we're going to convert the rectangle equation. Convert the rectangular equation. Oh, my bad. Convert rectangle to polar. So, rectangular to polar conversion. So basically, now I give you, for example, x squared plus y squared equals 9. Give you the rectangular equation. Ask you to find the polar equation. We still use those formulas. X equals r cosine theta. So you change x into r cosine. Convert the rectangle into polar is much simpler, because you just replace x by r cosine, replace r by y by r sine, and that's it. But you have to simplify sometimes. For example, this one, you can simplify more. R squared cosine theta squared plus r squared sine theta squared equals 9. You got r squared equals 9. Because r squared factored out, you have r squared cosine theta squared plus sine theta squared equals 9. So you got r squared equals 9, and you got r equals 3, which is a circle. R equals 3. It's a circle, and this is a circle as well. My center is 0, 0. R equals 3. All right. So next one, xy equals 4. So I'll give you 20 seconds to work at this one by yourself. Okay, so I think I'm going to call a student here. Tell me what your answer is. Jasper, could you tell me what you got?
Okay. You have r theta times r sine of theta equals 4.
Okay. So what next?
And then you have r squared cosine of theta sine of theta equals 4.
Okay. Anything else?
Part of line, so part of.
Okay.
I think we can simplify cosine theta, sine theta
Very good.
to PR squared sine 2 theta equals to that one.
Okay. So you just multiply both. You can do that. You can multiply both sides by 2 because you need 2. Is 2 sine theta cosine theta equals sine 2 theta. Very good, Lacey. You can see that. So 2 sine cosine equals sine 2 theta. So you got r squared equals, you multiply both sides by 2, you got an 8 over sine 2 theta. So in the end, normally in the polar equation, you would write r equals something. So r equals 8 sine 2 theta. Okay, so our function have whatever theta here. Okay, so that's the final. Normally we would write down that. It's just more. It's much easier for you to look at it and also to graph it. Give you a theta, give you r. Give you a theta, give you r. So once I give you a theta 0, you can find r equals what? Give you a theta equals not this one. Give theta equals pi over 3, what is r? Give you a theta equals pi over 2, what is r? So you can graph it, okay? So the requirement for this one, you have to simplify a little bit more, which is not really hard at all. You divide all the theta into the other side. You get r equals what? Okay, so number 3, thank you very much, Jasper. It's good. And number 3 is y squared equals 9x. All right. All right, I'm going to call student here. It should not be really hard at all. Taylor, could you please tell me what you got?
Well, I got r sine theta squared equals 9 times r cosine theta.
Very good.
And I wasn't too sure where to go from there.
So simplify it. R squared sine theta squared equals 9r cosine theta. I have r squared, I have r here. We can divide both sides by r. So it's r sine theta squared equals 9 cosine theta. So my final goal is find r equals what? So 9 cosine sine theta squared. And that's it. Okay. Thank you very much, Taylor. Which is good. And then once you simplify that from here to here, then you just solve for r. And that's it. Okay, solve for r. Or r squared is okay. And you just have r on the left and whatever you have on the right hand side. That's it. Okay. So I think we should be fine with convert the rectangular equation to polar equation. Convert y and x into r and theta. That's what to do for that. And next, using graphing utility to graph the polar equation. If you have graphing calculator, I'm assuming you all have graphing calculator, right? Since you all have different graphing calculator, it's very hard for me to explain one by one. But you can go back home and do it yourself using graphing calculator. But I can tell you but you cannot, when you do a test, you cannot use the computer, right? So you can learn that by yourself, how to graph the calculator, how to graph the calculator, graphing polar equations, I think. There's something, okay, this one. In your, there's so many. Wait. Okay, so to graph a polar equation, you can use your own graphing calculator. For this one, if I do it online, it's pretty simple. For example, if I want to do r equals 2 minus 5 cosine, which is you type in 5 cosine, and the theta, you just need to do THE theta, right? Okay. So now this is a polar equation. R equals 5 minus cosine theta. You type in, you will get this equation. Okay. So graphing picture. Your graphing calculator should have that function. Okay. If you need help, you can Google your calculator name, like a TI-83 mode, and graphing polar equation. You should be able to find the instruction how to use it. It should not be very hard to graph polar equation. And the first one, we just did r equals 2 minus 5 cosine theta, and we have the picture as like got it. Okay, going back. Alright, so let's make another one. Second one, we just do simple ones. So what we checked. Okay, for example, we just did one, which is r equal 3. You can see it's just a circle, right? We'll just do that one. So you can graph any polar equation here. Okay. So we also did one of the previous example is r equals what? We did several examples today. So r equals what's the first example we did? Second example we did. This one, r equals 3 sine theta, and I said is like this. Center is 0, 0, 3 halves, and 3 halves. What you do is r equals 3 sine theta. You can tell this is a circle. The x-axis, center is 3 halves, radius 3 halves. So you can use the graphing calculator to graph the polar equation. Okay. All right. So you can explore that using graphing calculator by yourself. The next one, we're going to continue with the derivative. How do we find the derivative? So at the slope and tangent line of the polar equation. Since we have x equals r cosine theta, y equals r sine theta. Well, from the previous example, all the previous examples, we know r is what? R is a function of theta as well. We got r equals 3 sine theta. You see r itself is a theta function. It's a function with respect to theta. You see r is a function with respect to theta. So r itself is a function of theta, so we have f of theta cosine theta. Okay. The r is a function of theta, we just put f theta or sine theta. In the previous course, we learned that for the parametric equation, this is the parametric equation. X equals f of t, y equals g of t. You know that, right? So it's a over theta. Just previous we used t. It's a parametric equation. All right. So we have if f is differentiable, is a differentiable function of theta, then the slope of the tangent line to the graph of f theta at r theta is So previously I got dy over dx. If you remember that, the parametric equation equals dy over dt. Before, right? We got dy over dt and dx over dt. That's the previous we got. But now, what do we have? We don't have the parametric equation. Parametric equation, the parameter is theta. We have a theta here, have theta here, have theta here. So we don't have t. So instead of doing t, we do dy over d theta and dx of d theta. Given function x equals f theta cosine theta, y equals f theta sine theta. I would like to ask a student here, what is the derivative of this one and this one? How do I take the derivative of the dy over d theta? Probably going to ask a student here, see if you can tell me. Okay. Luke, could you please tell me dy over d theta here? What do you think the derivative is?
I'm really not sure what the derivative would be.
So we have f a function and another function here. I just give another example. If my function is 3 tangent and sine theta, how are you going to take the derivative of this one? Look, could you please tell me this one? Oh, Lacey? Okay. So when you do the derivative of this one, we say this is the function of theta, this is sine theta. When you take the derivative, we have two functions multiplied together. It's product. So we're going to use product rule. Lacey, what do you say?
We're going to use the
Yeah, product rule. So product of dy over dy over d theta is f prime of theta first derivative first, multiply the second, plus keep the first, derivative second is sine is cosine. In a similar way, we do the dx of d theta here. So derivative of the first is f prime of theta, keep the second, plus, since the cosine is negative sign, so plus becomes minus. It is plus, okay, its product is plus. Since the derivative cosine is negative sign, so it's minus f sine. Okay, so this here, we basically use the product rule on both. X equals f cosine f sine, use the product rule on this. Alright. And so that's how we did this one. Okay. So this is a theorem or formula you can use for the slope of a tangent line. So next, we're going to look at the example. Find dy over dx and the slope of tangent line at the following points. So first example, first one, given r equals 2 plus 3 sine theta at 5 pi over 2. And the negative 1, 3 pi over 2. Okay. So, since r equals 2 plus 3 sine theta, so we got x, y equals r sine theta. And r equals this. So we got y equals r. R is 2. So it's 2 plus 3 sine theta times sine theta. Okay. Okay. And x equals r cosine. So r is a function of theta, so it's 2 plus sine theta. This is r. This is r. This is r, right? R cosine. So it's r cosine theta. So I have y and x. What I need to do next is dy over dx. dy over dx is dy over d theta over dx over d theta. So here, dy over d theta with its product rule. Derivative of 2 is 0, derivative of sine is cosine. So it's 3 cosine theta, sine theta. Plus, keep the first, 2 plus 3 sine theta. Derivative of sine is cosine. And derivative of this one, dx over d theta. So 2 plus sine, which is cosine. Oh, I missed a 3 here. 3 cosine and cosine. Minus, keep the first 2 plus 3 sine, due to the cosine sine. Okay. So just use the product rule and also the sine and cosine derivatives. And I think we can simplify it. 3 cosine sine, 3 sine cosine. So you can combine like terms, become 6 sine cosine. Oh, 2, my bad. It's 2, you distribute that. It's 2 cosine theta. Okay, simplify it like that. And this one is going to be 3 cosine theta square minus 2 sine theta minus 3 sine theta square. Okay, so now I'm looking for the points, looking at the derivatives, the slope of tangent line 5 and pi over 2. So I'm looking at pi of theta equals pi over 2. You just need to plug it in. So dy over dx equals, plug pi over 2 into the function, it's going to be 0. Plug pi over 2 here, so it's 2 times 0, right? 2 times 0 plus 6 times pi over 2 is 1, cosine pi over 2 is 0. And the bottom is 3 times 0 minus 2 times 1 minus 3 times 1. Well, you got 0, 0, just 0, right? It's not a big problem. Because cosine is 0, cosine is 0, so the whole thing is 0, so it's 0. So I'm also looking at theta equals, what? 3 pi over 2, right? Well, if 3 pi over 2 dy over dx is also 0 because cosine is 0, so it's just a 0 over because cosine 3 pi over 2 is 0. The bottom is negative 1. You know that is 0 over 0 minus 2 times negative 1 minus 3 times negative 1 square. Well, you know that's going to be 0 over something which is 0. Okay, so that's how you find the derivative and the certain point. So tomorrow we're going to look at 2 more examples. I'm missing 1 more example. And 2 more example, 1 more example. Then we're going to continue on the area and arc length of the polar coordinates. Okay, on the area of the polar region tomorrow, and then we'll continue. Thank you very much. And I'm going to sign the homework for this week later today. And I hope you all have already finished your homework for last week. I'll see you tomorrow. Thanks.